The halogen group is a group in the periodic table consisting of 5 chemically related elements: fluorine, chlorine, bromine, iodine, and acetine. The word halogen itself means salt former in Greek. Halogens have properties that enable them to react with other elements to form important salts, such as sodium chloride, also known as table salt. It is the only element group that has similarities in the halogen group are that they all produce or create salt, as their name entitles, hal, salt, and gen, to produce, because they all produce sodium salts of similar properties. They also have resemblance with their general chemical behavior. To be a part of the halogen group, they must all carry 7 valence electrons in their outermost shell. There are differences, as this is crucial, as then they would be the same element. The differences between the two successive elements being most pronounced with fluorine and chlorine. Fluorine is the most reactive out of the halogens. The boiling points of the halogens increase. Therefore, the physical state of the elements down the group changes from gaseous fluorine to solid iodine. Down the group, the colours of the element darken, and the M peak and the B peak increase. The reactivity of the elements increase from iodine up to fluorine. The reasoning for the placement on the periodic table is that they all have 7 valence electrons on their outermost shell and that they are very active towards each other in the periodic table. My chosen element is iodine. It is found in the halogen group of the periodic table and is in the 5th period. Its atomic number is 53. The mass number is 127 roughly, atomic mass units. Iodine is a nonmetal. The appearance of a solid iodine consists of shiny bluish-black crystals, but iodine vapors are a purple gas. Iodine is named after the appearance of the iodine vapors. At iodize is the Greek word of purple. Iodine is a solid and hard in its natural form. It reacts with very few elements, but does not react with water, only a solution of iodide in water. They react well with the elements in Group 1 and Group 2. To combat iodine deficiency, table salt is often enriched with iodine by adding small amounts of sodium iodine, or potassium iodate. The product is referred to as iodized salt. The boiling point of iodine is 457.4 Kelvin, or 180 degrees Celsius. The melting point of iodine is 386.85 Kelvin, or 113.7 degrees Celsius. The amount of protons and electrons in iodine is 53. The amount of neutrons in iodine is 74. The electrons are arranged in this number sequence: 2, 8, 18, 18, 7. Iodine only fits where it fits because, like the other halogens in its group, it has 7 valence electrons in its outermost shell, and it has 53 protons and electrons. It positions it next to the obvious 52 element of beryllium and 54 element of xenon. Iodine is valuable. A kilo of iodine crystal estimates to around $37. Iodine is fairly rare in both the Earth's crusts and in the solar system. Iodine is the 47th most abundant element in the solar system. Of the several places in which iodine occurs in its nature, only 2 sources are useful commercially: the Calachee, found in Chile, and the iodine-containing brines of gas and oil fields, especially in Japan and the United States. Humans use iodine for reducing thyroid hormone and can kill fungus, bacteria, and other microorganisms such as Amoebas. A specific kind of iodine called potassium iodide is also used to treat, but not prevent, the effects of a radioactive accident. If iodine is a compound, it can be used as a table salt. Tasteless, non-flammable gases. The noble gases have the uses that are derived from their other chemical properties. The very low boiling points and melting points of the noble gases make them useful in the study of matter at extremely low temperatures. The halogen group is very active, whereas the noble gases are unreactive. Thank you for listening. I hope you enjoyed. Here's my bibliography.